The main difference with these logarithmic equations is that we have a log expression on one side of the equation, and on the other side of the equation, we just have a number with no logarithm attached to it. So with this one, we can't use that property of equality unless we wanted to try to make that number into a log expression with the same base as the other side, which is unnecessarily complicated. So what we're going to do instead is we're going to change our logarithm equation into an exponential equation. So quick reminder to do that, we take the base of the logarithm, then we get the power from the other side of the equation. So 4 to the 0 is equal to, and then we have the argument, so 2x minus 3. Now once we've done that, we've gotten the logarithm out of the way, so now we can solve the resulting equation here. I'm going to evaluate 4 to the power 0 first. That's a 1. Anything to the power 0 is 1. And from there, it's fairly simple to solve. So I'd add 3 to both sides and then divide by 2. Now, like before, I do need to make sure that I'm not ending up with an extraneous solution when I do this. So I'm going to take this and put it back in wherever there's a logarithm into the argument. It has to make sure, you have to make sure that the argument is still positive if you put that value of x in. So when I put 2 in, I get 2 times 2, which is 4 minus 3. That's still positive, so it's all good. So this is a good answer there. Okay, let's try one more like that. So over here, I've got log base 1/3 of 4x minus 5 is equal to negative 3. Once again, I've got a logarithm on one side and I've got just a plain number on the other side. So I can't use the property of equality. So I'm going to change this to its exponential form instead. So I take the base of the logarithm, 1/3, and I raise it to the power of the number that's after the equal sign. So negative 3 is equal to the argument of the logarithm. Okay, now 1/3 to the negative 3 power. A negative power means you take the reciprocal of the base. So this would be the same as 3 to the 3rd power. And then from there, it's fairly simple to solve there. 3 to the 3rd is 27. Then I could add 5 to both sides, so that would give me 32 equals 4x, and then divide by 4. So x is 8. Now, once again, I could end up with an extraneous solution, so I do need to check before I declare this my answer. So if I put in 8 in place of x, remember the thing that I'm looking for is I want to make sure that the argument is positive with this x value inputted. So 4 times 8 is 32. 32 minus 5 is still positive. So 8 is a good answer. Okay, now you try a couple problems.